Hope my screen is visible, right, to everyone?
Yes, sir.
Okay. So morning we have seen up to this. Okay, like up to see Spain image and Spain mask. Okay, so let me get into the second part. Okay, where we are going to do the data pre-processing with DALI. Okay, so DAL is nothing but it's a data loading library. That is a NVIDIA data loading library. So deep learning model requires vast amount of data to produce accurate prediction, and these needs become more significant as models grow in size. That is, so whenever we are having a very vast amount of data, the model accurate prediction is very high. Okay, so and this needs becomes more significant as models grows in size and complexity. Okay, so on this also, whenever we are increasing the data set, the significance of the model also grows, and the complexity of the models will also grow. Okay, so in order to overcome this problem, in order to tackle the problem, okay, so we need to do some data pre-processing techniques like resizing the image, denoising, normalizing to the standard values, uh, and then we changing the degree of pre-processing, degree of the image to some certain level. Okay, so these are some of the techniques we need to perform in order to reduce that memory consumption of the entire data set. Okay, so this is the overall picture of NVIDIA data loading library. So we will have the input lib data. It may be an image, audio, or video. Okay, image, audio, video, and so once the data, once we have the input data, then we will give it to the NVIDIA data loading library. Okay, so we need to decode the inputs. Okay, so decoding is nothing but providing the values of zeros and ones. I hope everyone aware that most of the digital and all the digital system only know about the digital values of zeros and ones. Okay, and then we are having a GPU accelerated augmentation. Okay, so can anyone say what do you mean by augmentation? Data augmentation. So what do you mean by data augmentation? Okay, so the data augmentation is nothing but whenever we are having a very small amount of data. Let us take an example. I have only 10 images. Okay, so if I want to increase the number of data points or number of images in the data set, so what I can do is I will try to increase the number of images. Okay, so how can we do that? Okay, so let us take an example. I have 10 images. Okay, let us take one images as for example. Okay, so with the help of this single image, I can generate the image with the different angles. I can generate the image with the different cropping ratio. I can generate the images with either flip, horizontal flip or vertical flip, and then I can go with random brightness, and then I can apply some Gaussian noise over the image. Okay, so let us take an example. I have provide just a 5 pre-processing technique like augment, rotation, flipping, zoom. We can change the brightness, and we can add the noise, different noise. Okay, so now the single image has been converted into 5 images. Okay, so 5 plus 1, that is our original image. Totally we are having a 6 images. Okay, so if I apply this technique for all the other images in our data points, so what we will get? So we'll get around 60 data points. So previously we are having a 10, now it has been increased to 60. Okay, so that is the power of augmentation. So here in NVIDIA data loading library, so the GPU accelerator has been taken, the data augmentation has been taken care by the GPU accelerator. That is, accelerator is nothing but we are having a parallel compartments to do the processing. Okay, and then we have once we have done with this DALI library, so then it is a pre-processed data. So once we have the pre-processed data, so we can either pass it to the any of the one deep learning frameworks. Okay, so TensorFlow, PyTorch, Paddle, MXNet, like that. Okay, so the NVIDIA data loading library is a library for data loading and pre-processing to accelerate the deep learning applications. Okay, so it provides a collection of highly optimized building blocks for loading and processing in image, video, and audio data. Okay, so DALI addresses the problem of the CPU bottleneck by offloading data pre-processing to the GPU. Okay, so it also offers some of the powerful features. Okay, so that is it can support the input formats including the image file formats, and then it relies on the own execution engine built to maximize the throughput of the input pipeline. That is, so the DALI library will have their separate execution engine. Okay, so this separate execution engine will try to maximize the throughput of the input pipeline. Okay, and it can be used as a portable drop-in replacement for built-in data loaders. Like we have the data loaders for in Keras, TensorFlow. Okay, so instead of that, we can directly use this DALI library portable drop-in replacement data loaders. Okay, to load the data directly into the Jupyter notebook or Kaggle notebook or Colab. So, and it has a feature such as prefetching, parallel execution. So you know that power of GPUs. Okay, so the only difference between the CPU and one of the difference between the CPU and GPU is that So GPU work on the instructions based on the sequence. Okay, so it will perform based on the sequence by sequence. But if you take the GPUs, that is the graphical processing units, it executes based on the parallel mechanism. Okay, so that is what it makes the difference when compared to the CPU in terms of the maximize the throughput, low latency. Okay, so this is what advantage of GPUs. And then this library also supports different frameworks like PyTorch, TensorFlow, MXNet. Okay, so I hope everyone know about the TensorFlow is developed by the Google, and PyTorch is owned by the Facebook, and MXNet is owned by. So say where I my internet connectivity get disconnected. Okay, so let me quick go through this. Okay, so in order to deal with that NVIDIA Rally library, I have to some of the necessary. Okay, so from NVIDIA.DALI pipeline import pipe. Okay, run this code, and the total number of batches is equal to 4. That is, I am going to divide the entire data sets into 4 batches to process the images. Okay, so I have created the pipeline. Okay, I am declaring the batch size, the number of that. I am going to use so number of that is the device ID. That is the GPU 0 will work as a 4 separate. Okay. So after doing so, that is the augmentation. Okay. So I'm going to do a resizing, flipping the image. mutation or reduction. So we'll have this here, that is ROI, that is the rate or region of. So because when I'm doing this, let us take an example. I have the image size of 512. Okay, so for our particular application, the entire 512 will not be okay. So, but we need to have some region of interest in that particular image to declare the output. Okay, so this is ROI, and we are going to make different ROIs. Okay, so to increase the number of data samples. So it will take some time to run because it's doing some manipulations. So let me give 1 minute to do this training in the Excel. Okay, so now the training has been completed, and then I'm going to pass the entire data augmentation pipeline. So then we can see some of the augmented image to get the clear idea about how the data augmentation is working. Okay, you can see this was the original image. Okay, so with respect to the different resizing and horizontal flipping and vertical flipping, it has been changed. Okay, so this is the way we need to increase the images. So next I can do it on batch wise also. Okay, you can see here the mask has not been produced. Okay, so because this is one of the problem with dealing with the image segmentation problem also. Okay, so we need to be very careful in both the image and mask are matched. Then I can check for the random rotation. So you can see we are having a different rotation of images. Okay, and also we have currently generated the mask over this. But if you take this particular image, the mask is not that much sufficient, right? Because we are having the water bodies here, but the mask generator is not having that water bodies. Okay, so this is the different data augmentation technique, especially the DALI library, to increase the data augmentation. Okay, so any doubt with respect to this? So why I'm impressing more on the data augmentation is most of the work we are going to deal with the data. Okay, so these are some of the techniques we are having to increase the number of data. So any doubt with respect to this?
Hello, sir.
Yeah, 1 minute. Yeah, yeah.
Sir, is there any limitations or limited count for making of image augmentations? For this image means this is the count we have to do for making of augmentations.
No, so it is not.
Because we are doing slight changes in the image and making as an new image like. So, is there any count numbers? Or there some limitations? These many number of counts only we able to do for each and every image augmentations like.
So there is a no
And
definite.
any type of
Tell me.
what type of changes? What are the different types of changes we have to able to make in that image?
Okay. So with respect to data augmentation, okay, so we need to first consider about that what is your application. Okay, so let us take an example. If I have the if I want to classify the digits, okay, so for classifying the digits I can't able to use the vertical or horizontal flipping. Okay, if I use the vertical and horizontal flipping, so the digits will be of different orientation or different angle, then your model will not able to understand what is exactly happening in that what exactly the digit represents. Okay, so likewise for some of the applications we need to be very careful in using the image augmentation. Okay, so some of the image augmentation what we have discussed are rotation, scaling, random cropping, increase the brightness, and then we are having a Gaussian. Okay, so we can add the Gaussian noise or we can just blur the image. So there are n number of data augmentation techniques we are having, but we need to be very precise with respect to our what would I say, with our applications.
Okay, so thank you.
So any other doubts from audience? Any doubts? Okay, so this is with respect to that how we can make use of this IN GPUs to solve this type of problems. Okay, so then we will discuss about RN for health monitoring. Okay, so this is what we have planned for this particular session. Okay, so can anyone say what is mean by RNN and where we are using that?
Is a recurrent neural network. We have to use where we are going to take some repeated processing for finding some accurate resultant.
Okay, so the RNN is nothing but it's a recurrent neural network. So whenever we are having the data with time dependent or the next output will be depend upon the previous input. Okay, so this is where we are whatever we are having the sequential data, then we have to definitely pitch into the RNN model. Okay, so let me quickly share my screen and explain what do you mean by first RNN first. Okay, so I'm not going to any presentation mode. I'm just going to use of this simple diagram to give an idea about RNN. Okay, so we are having the inputs here. Okay, so in CNN, what I will do, it is a concurrent way. Okay, so the input will be passed from the input to the output. Okay, so here we are having some embedding layers. Okay, so this is called word embedding layer. The layers are character embedding, and then we are having the RNN. Okay, so in the RNN we are having a forward layer and backward layer. Okay, so you can see we are having some feedback here. Okay, so this input has passed directly to this node and also for this particular neuron. Okay, so this is what a RNN. Okay, so RNN, what it will do is it will try to capture the dependent. Okay, so let us take an example. I am passing the input like you will never. Okay, so the RNN, what it will do is it will try to predict the next word. Okay, so the next word is believe here. Okay, but RNN will suggest some other words. Okay, so one of the best example is, so I hope everyone using that Gmail, right? Google Mail. Okay, so in Google Mail we are having we are getting the uh, future suggestions, word suggestions. Okay, so that is our best example for RNN. Okay, so but in RNN we are having the problem called vanishing gradient problem. Okay, so whenever there is so much of training happen in that particular RNN model, the information or gradient will be lost, vanished. So vanished is nothing but there is no more further training will happen. Okay, and also if you want to hold some information for long time, okay, let us take an example. I have some information, I want to hold that information for 100 milliseconds, but due to the excessive training, your RN algorithm, what it will try to do is at the 50 or 55 milliseconds, that information will be vanished. Okay, so this is one of the drawback what with RNN algorithm. Okay, so to overcome this particular problem, so we are moving into the next model called long short term memory. Okay, so which is the short form called LSTM. Okay, so the understanding of LSTM is very important. Okay, so because most of the sequential models nowadays are using the LSTM algorithm. Okay, so the LSTM algorithm is, model is nothing but we are having three gates: input gate, forget gate, and output gate. Okay, So the input gate will try to process all the input signals or input which is whatever we are getting. Okay. So the forget gate, what it will do is, okay, so the forget gate, what it will do is it will try to hold the information for a very long time. Okay, so in RNN you know that we are having the problem of called vanishing gradient. In order to overcome that, we are going to have some one more gate called forget gate. So this forget will decide whether to hold the information for a long time or not. Okay, so if the model is satisfied and you are, and there is no need to hold that information, so we need to pass the signal to the forget gate to uh, remove the, to forget get that particular information. Okay, so it will be done with the help of tan h or relu function. Okay, so the relu is nothing but whenever we are having the values something below the threshold, it will throw the output as 0. Okay, if it is above the threshold, it will throw the output as 1. Okay, so we'll use some activation function to do that process. But the primary thing is in RNN we are having the problem of vanishing gradient, but with the help of long short-term memory and also with the help of that forget gate, will try to hold the information for some period of time. Okay, so if you are satisfied that if you are know that so this information is no longer valid, you can just remove that particular information from the forget gate. Okay, so this is a major difference between RNN and LSTM. Okay, so in this particular session we are going to discuss about ECG odd bit prediction using the LSTM algorithm. Okay, so let me quickly share my screen. Okay, so we are having around 4 sets. So one is normal.csv. So this is the normal odd bit. Okay, I'm just taking the raw data. I don't give any data with the column name. So and I am having the abnormal data set. So these are the abnormal features. So this is a Kaggle platform, and I am using the going to use the GPU accelerated environment. So this Kaggle will provide a 30 hours of free GPU per week. Okay, so you can make use of your own algorithm for your own application also. So let me run this first cell. Okay, so import numpy as np, import pandas as pd. Okay, you know that. So whenever you are dealing with any machine learning algorithm or any deep learning algorithm, for data formatting and numerical computation is common. Okay, so I'm having totally 4 files in our data folder. One is abnormal.csv, normal.csv, test.csv, train.csv. So import math, import random, import pickle, import iter tools. Okay, so for doing some basic mathematics like calculating the square root and also for using the pi, we need to import this math. Okay, this random will try to generate the random weights, or try, if you want to use the random images, we can use the random. And pickle file is used to store the trained model in the pickle format. Okay, and then iter tools for doing some basic stuffs. Okay, I will show what are the iter tools will do. So, and also from sklearn.metrics, I am going to use accuracy score, classification report, confusion matrix, and label ranking, average prediction score. So that is whatever we are getting from the classification matrix, and we are going to find in the average of precision score. And from sklearn.utils, so if you want to shuffle your entire data set, so you can make use of this particular library. Okay, you can shuffle your entire data, and also you can resample the data. So whenever we are having dealing with some bagging algorithm, so if you want to resample, then we can use this. Okay, so here we are going to use the signal resampling, because so you know the ECG is a signal. Okay, it is not like an image, so it is a signal. Okay, so we are going to do some processing over this. Okay, and we have discussed morning that we will do the categorical encoding. Okay, so here we are going to use the one-not encoding. Okay, so can anyone say what do you mean by one-not encoding? I hope if there is any communication faculties here in the group, so they know about what is uh, encoding. What do you mean by encoding? Can anyone say? What do you mean by encoding? Okay, so the encoding is nothing but whenever we have to encode the some of the important values. Okay, let us take an example. I want to pass my name as a secret manner. Okay, like I want to pass my name Chandran as a secret. Okay, so what the encoding will do is, so it will try to encode the features. Okay, for each and every alphabet, every character, we will have the number. Okay, like CHANDRAN. Okay, so instead of that, I will pass 10101010. Okay, so each represents one of the each character represents one of the code. So that is encoding. Okay, so the one not encoding, what it will do is it will do create the, let us take an example. I have two classes 0 1 fire dog or cat. Okay, so the one not encoding, what it will do is it will try to assign 0 to dog and 1 to cat. Okay, so this is what the function of one not encoding. And then we are having the keras.models.import model, and this is some of the layers like dense layer, convolution only, max pooling, soft max, flat and activation functions. Okay, and we are going to have the optimizers. So this optimizer is nothing but whenever we are dealing with the neural networks, there is a concept called backpropagation algorithm. Okay, so the backpropagation algorithm is nothing but if you want to propagate your error from output to the input, then we have to use the backpropagation algorithm. Okay, so the backpropagation, what it will do is, so it will try to update the weights and bias. Okay, or it will try to optimize the weights and bias. Okay, so in order to optimize the weights and bias, we need to do, or we need to have some optimization algorithm. Okay, so here we are using the Adam. In general, we are having AdaGrad, RMS prop, stochastic gradient descent, mini batch gradient descent. Okay, and then we are having so we are having different optimizers. Okay, so but why we are using the Adam is one of the most prominent optimizer for all the deep learning applications. Okay, so the Adam is nothing but it is a combination of RMS prop and stochastic gradient. Okay, so in the name itself it is suggesting that it is an adaptive moment estimation. So it will try to adapt the momentum. Okay, like say if the learning should be in the forward phase or if the learning should be in the back phase, so that can be taken care by this Adam optimizer. Okay, so morning I have said, right, so instead of whenever we are increasing the number of epochs, so what happened, the some point the accuracy start decreasing. Okay, so in order to do so, so we are going to use the learning rate scheduler. Okay, so this learning rate scheduler, what it will do is it will try to increase or decrease the learning rate depending upon the model performance with respect to the validation score during the training phase. Okay, so let me run this particular cell. So here we are getting the using TensorFlow backend. So the TensorFlow backend is nothing but, so the Keras, whatever the model we are building, okay, it will be the front end will be the Keras and backend is the TensorFlow. Okay. So I'm going to read test and train data. So I'm going to resample the entire data sets. Okay, for each and every data from the has been range sampler. Okay, so each and every value having the sample of 20,000. Totally we are having a 0 to 4. Totally we are having the 5 samples. Okay, and we need to balance the data set with respect to training and testing. So you can see, so before all the balancing, so we are having a class 0 of 72,000, class 4 of 6,400, class 2 of 5,700, on class 1 of 2,200 plus class 3 of 641. Okay, so after the balance data, you can see each and every train data that has been increased to 20,000. and the test rate also increased to 20,000. Okay, so this is the data balancing. So and also we are going to use the min max scaler. Okay, so the min max scaler, what it will do is, so it will try to make the features or make the feature values in the columns into the certain range. Okay, so why we are doing so is that, so it tried to reduce the computation complexity, and also it also tried to reduce the ambiguity of the systems. Okay, so that's what we are using the min max scaler. You can see that now the maximum value would be like 0 to 1. So we don't get any other values more than 0 to more than 1 or less than 0. So next is a model. Okay, these are the input features. Okay. So model.add. So here also whatever we are dealing. Okay. So here also the tense layer is common. Everything is common. Only thing is the word embedding. Okay. We are using the word embedding vector. So let me run this particular cell. Okay, so here what we are using is we are just using the simple CNN model. Okay, so after running this, after this running is completed, we will see how to make use of the run. So you can see the initial accuracy would be like started from 0.83. Now it has been near to 0.96. Okay, so we are having a 0.9641. So this is the overall accuracy with respect to the basic CNN. Okay, so let me check same for bidirectional LSTM. Okay, just give me a second, guys. Okay, so now I have renamed the code. Okay, so I am going to use the bidirectional LSTM here. Okay, so this is the overall summary of the model. You can see before that we are having the dense layers. Now it has been embedding layer in the LSTM and dense layer. Okay, so the total number of trainable parameters is 4,68,440. Okay, so you can see now that how the training has been taken. Okay, it's taking so much of time to train. Only for I'm going to train for 3 epochs, but it is taking so much of time to complete the training. Okay, so that is the one of the problem with this type of the LSTM algorithms. Okay, so any doubt with respect to this guys for RNN? Because it will take to time to complete the training. If you have any doubts, you can ask. The next step would be like plotting the graph only. That's it. Any doubts from the audience side?
Respected faculties, if you have any doubt, please feel free to ask. So, whatever doubt you are having regarding deep learning or an LSTM, so you feel free to ask with Chandran sir.
So I hope it is difficult for you to understand. Yeah. So what is the purpose of by LSTM? Okay. So by LSTM is nothing but if you use the LSTM, it will pass the information one way only. Okay, from the input to output. So if you want to communicate from the output to input, okay, we can make use of the bidirectional LSTM. So it is like a feedback path, which is very convenient in the real time use cases. Okay, bidirectional stands for bidirectional LSTM. It will move both the way, forward and backward. Any other questions from audience side? So I can share this notebook with the organizers. Okay, you can just take it from them. Okay, so no need to worry about that coding part and all. Because it is around 1 lakh data points. Only we have completed at around 10,000. Okay. Saran sir, if there is any questions, ask them to ask there. Otherwise, we can wind up the session. I will share the notebook with you.
Hello, hello, Chandran sir.
Yes, sir.
Uh, is it over, sir?
Yes, it is completed. I will share the notebook with you
Thank you, sir.
because it will take half an hour to complete the training
Yeah,
because
thank
it
you,
is
sir.
around 1 lakh data points.
Thank you, sir. Faculty, respected faculties, anybody having a doubt with above RNN or LSTM or any other deep learning relevant topic means, so feel free to ask. Unless we have to wind up the session now. So we are having a vote of thanks session now. If you have any doubt, so feel free to ask. Am I audible? Uh,
Yes, sir. Audible, sir.
Thank you. Um, Respected faculties, I hope you don't have any doubt now. So we are done the end of the session now. Um, Sir, HOD sir. Okay. So we are done the end of the session now. So Priyanka,
Yes, sir.
so you have to start now.
Yeah, okay, sir. Thank you, sir. A very good evening, everyone. I'm Priyanka from third year IT department. Now I'm here to gives me an immersion's pleasure to deliver the vote of thanks for this today event and the technical events of the seminar on impact of climate change on human health using a deep learning algorithms. So first, I would like to thank our chairman, sir. Thank you, sir. And then I would like to our principal, sir. Thank you, sir. And I would like to thank to our dean, ma'am. Thank you, ma'am. And now I would like to our resource person, Mr. V. Chandran, certified NVDA instructor for deep learning Chennai. Thank you, sir. And once again, I would like to our resource person, Mr. C. Prabhakaran, decision scientist, Bangalore. Thank you, sir. And now I would like to our department HOD, sir. Thank you, sir. And once again, I thanks one and all present here. And I would like to thanks our faculty members, staff members, and students and participants and the volunteers. It is last but not the least our beloved audience for making this function such a grand success. So once again, I thanks one and all present here. Thank you. Thank you to all. Thank you, sir.
Thank you, Priyanka.
Thank you, everyone.
Thank you, faculty members and students, Chandran sir and Prabhakaran sir, and those are from inside and outside of the Kongunadu College. So, for making this session as a wonderful one. So, I hope you are enjoyed this session. You have able to gather a lot of new knowledges relevant to the deep learning and the important that concept of impact of human health relevant to climate change. So how the climate change is affect to the human health, that as we have to analyze that you are going to gather a lot of details and the different types of deep learning algorithms which is used to analyze the above concept. So I hope this should be becoming a great success. So thank you for all the faculty members. So for making this session as an excellent one. So now we have to post the feedback link in the chat box. So so all of you have to fill this feedback form without fail. So this will be helpful for making sending you an e-certificate. So thank you once again. Thank you for all. So please do fill the feedback form, everyone, without fail. Thank you.